I suspect for the review from 38 through 54, there are going to be a number of questions if we've done that one. That's why it was a shorter set. I definitely want to start talking with 38, and then we should have opportunities for whatever questions you have to get through this. And this is your chance to be a YouTube star, because I'm going to record this one just because we have so many people missing, and then I can say you can go back and look at them rather than me take my time. So thank you for being here. Find the probability of getting only one yellow light out of 5 traffic lights. This is often missed, and the distractor answer that I would put there isn't there. I suspect a number of people said, assume red, green, and yellow are equally likely outcomes, so each one has a probability of 1/3. I assume the common mistake to make would say, okay, let's get the yellow. It would be 1/3 we get a yellow light, times 2/3 we don't get a yellow light, times 2/3 we don't, times 2/3 we don't, times 2/3 we don't. So we would set that up as well. I win if I get a yellow light and not 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 a yellow light. But that is strictly implying that I got the yellow light at the first light. I could have not gotten a yellow here and then gotten a yellow there. Or I could have gotten a yellow at the 3rd light, or the 4th light, or the 5th light. So it's the probability that this happens, and this, and this, and this, and this, or that. So plus all of these, plus all of those, plus all, but each one of these is the same. I've got a 1/3 and 4 2/3. So it is going to be 5 of these cases of 1/3 to the 1st times 2/3 to the 4th. That just accounts for all 5 possibilities of where I could get the yellow light. And that answer should be represented. I believe that's D. Is that okay? Just curious hands, how many of you originally just set that one up with 1/3 and 4 of the 2/3? Yeah. Okay. What else can we look at from 39 through 45? Yeah. 39. Yeah. Okay. Based on the statistics from the last 20 years, it was discerned that a drug used to reduce blood pressure caused side effects in 3% of patients who took it. 2 patients who took the medication were selected at random. Find the probability both patients had side effects. Well, in order for us to win in this case, the first person had to have side effects, and the second person had to have side effects. So the and implies multiplication, so this is 0.03 times 0.03, or 0.0009. Is that all right? Anybody have a question on 40? I'm just going to go through it. A coin is tossed and a die is rolled. What's the probability the coin shows tails? 1/2. And the die shows an even number? 1/2. 3/6. So 1/2 times 1/2, 1/4. 41. 15 balls numbered 1 to 15 are placed in an urn. 1 ball is selected at random. Find the probability the ball is not the number 10 ball. Well, 14 of them aren't. 14/15. I don't think that's going to cause a problem. How about 42 through all parabolas here? 42 through 44. Yep. Just do all of them? All right, yeah. Yeah, we certainly have the benefit of time for this. So we are looking for the vertex of this parabola. I need to get this in standard equation, which means I want my squared variable isolated and square completed on it. So I'm going to keep the x squareds on the left. I'm going to leave a blank. I'm going to subtract 8y and add 20. And at this point, I complete the square. So I want half of 4, 2. 2 squared is 4 plus 4. These are out of balance now. So I balance by adding 4 to this side. And I get x plus 2 squared equals negative 8y plus 24, or x plus 2 squared equals negative 8y minus 3. The vertex at the parabola is at hk. My most interesting value of x is negative 2. My most interesting value of y is 3. That's the location of the vertex. Now I'm just going to take that a step further because the next two problems ask for focus and directrix. So I'm going to just go ahead and find focus and directrix of this, and then we'll try the next ones. So if I was to graph this thing, negative 2, 3 is the vertex. Do we know what direction this is opening? It's an x squared parabola, so it's opening up or down. This negative value implies that it's opening in a negative direction. So this parabola is opening down. This negative 8 is in the position that 4 times p is in. So p is negative 2. Once again, we're opening in a negative direction. The focus must be down here 2. The directrix would be up 2 from there. So the location of the focus is negative 2, 1, and the equation of the directrix is y equals 5. Okay. So 43. Find the focus. I'm going to keep my y's on one side. Y squared minus 4y, leave a blank, equals 4x. Still in balance. Half of negative 4, negative 2 squared, positive 4. Out of balance. Back in balance. And I get y minus 2 squared equals 4 times x plus 1. So this, you can perhaps come up with the focus without graphing it, but I would highly recommend graphing this thing. I have a vertex at negative 1, 2. Most interesting value of x, most interesting value of y. This is y squared, so it opens right or left. In this case, it opens to the right because the p-value is positive. So this opens like this. 4p equals 4, so p is 1, placing the focus right here. So the focus is at 0, 2. If we wanted the directrix, 1 in the opposite direction, x equals negative 2. And find the directrix of the parabola. This one's in standard form. Y squared equals x. This opens to the right at 0, 0, and the value that's in the place of 4p is 1. P is 1/4. So the focus is 1/4 to the right. The directrix is 1/4 to the left. We're looking for the directrix. All of those points are to the left 1/4. That sounds like x equals negative 1/4. All good? One of the real key things to remember when we set these up and put them in standard form, x minus h squared equals 4p times y minus k. Maybe the most common mistake I see amongst people who have a pretty good idea what's going on is they think of this 4p, maybe it's in front of here. The squared part's isolated, which is convenient, because to complete the square, we want to get the squared part alone. All right, this is where 4p resides. And we're going to have to know the value of p to find focus and directrix. Ta-da! Got it. All right. Find the vertices of the ellipse. Well, you can probably do this without sketching it, but I'm going to sketch it. The center of the ellipse is at negative 1, 4. I go in an x direction, 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 away. And 1, 2, 3, 4, 5, 6, 7, 8 away. And then I could go up and down 6. So down 6, up 6, somewhere up here. But these are the vertices. They're on the longer axis. And that's 8 over from negative 1. So that is the point 7 and up 4. And 8 over from negative 1, negative 9 and 4. Easy enough. Find the foci of the ellipse. I'm going to sketch it. Might not need to sketch it here, but I'm going to sketch it. Center at 0, 0. We're going to go up and down 8. We're going to go left and right, root 28, which is a little bit more than 5. Maybe I'll just do this. 5 and 6. Negative 5, negative 6. Is that okay? We're between 5 and 6, root 28. So my ellipse looks like this, and it's taller than it is wide. So the foci are somewhere here and there. And we can't spell foci without C. A, in this case, is 8. B, in this case, is root 28. But I know that A is the longest, so A squared 64 equals B squared 28 plus C squared. So that gives me C squared equals, what would I get here, 36? That sound right? And C is plus or minus 6. So up 6, down 6 from 0, 0. The foci are located at 0 plus or minus 6. Find the center of the ellipse. I need to complete the square on x and y. I'm going to group my x's, factor out a 4, leave a blank, group my y's, factor out a 9, leave a blank, and subtract 37. Half of negative 8, negative 4 squared plus 16 out of balance. Half of 2, 1 squared 1 out of balance. When I put the 16 here, I didn't really add 16, I really added 4 times 16. Added 64. When I put the plus 1, I really added 9 plus 9. So I get 4 times x minus 4 squared plus 9 times y plus 1 squared is, let's see, 73, 37, that is 36. Now, at that point, truthfully, I could be done. In fact, even without balancing, if we look ahead, I was done before that, because all I really needed to know was what's the center. The center is at 4, negative 1. But if it was asking other questions, the next step, of course, would be to divide everything by 36, and I get x minus 4 squared on 9 plus y plus 1 squared on 4 equals 1. Now I could build it, graph it. Now I know what A is. A is 3. Now I know what B is. B is 2. I can figure out what C is. All good? Find the center of the hyperbola. Group the x's. Factor out the 9. Leave a blank. Group the y's. Factor out carefully the negative. Y squared minus 2y. Leave a blank. subtract 71. Half of 6, 3, 3 squared 9. Half of negative 2, negative 1 squared 1. Out of balance, however, I'm only looking for the center. So yeah, I could go through the whole process here like we just did on the last problem and get this in standard form, but this is going to end up factoring to an x plus 3 squared. And this is going to end up factoring to a y minus 1 squared. Therefore, our center is at negative 3, 1. Okay. If they ask for some other parts of it, yeah, we got a little bit more work to do. (49). Find the foci. You may be able to do this without graphing it. I'm going to graph it. Center at 2, negative 1. 2, negative 1. X, I'm going to move right and left 4. 1, 2, 3, 4. 1, 2, 3, 4. Y's, I'm going to move up 3. 1, 2, 3. And down 3. 1, 2, 3. That defines the box, which defines the hyperbolas. What direction do we open on positive or on x squared, positive x squareds? In x direction. So we open like this. Meaning A is our x distance, 4. B is our y distance, 3. And our foci are out in here. And they're the big ones. C's longer than A now. So that is c squared equals a squared plus b squared, or c is plus or minus 5. C is 5. So we're 5 steps away from 2. Center is 2, negative 1. 5 to the right of there would be 7, negative 1. And 5 to the left of there would be negative 3, negative 1. Just add 5, subtract 5. Okay, 50. The rectangular equation we're looking for, we've got parametric equations. Now, let's say you just get stuck here. We didn't spend too much time on this, but you remember your graphing calculator can graph in parametrics. You can go to mode parametric and you can graph these guys right here. And then you can see, does it look like that x squared plus 4? Because we should have a pretty good idea what x squared plus 4 looks like. Does it look like square root of x up 2? Does it look like a y squared parabola? If it looks like a y squared parabola, now we might have some issues. But if it's offset off the axes, it would be this one. But the way you probably really should handle this is, these are parametric because of the t. I wish the t's weren't there. I like the x. I like the y. We've got x is t squared. We've got y is t minus 2. But t may be replaced by y plus 2. If I solve this for t, t may be replaced by y plus 2. So I'm going to put y plus 2 right here. And I get x equals y plus 2 squared. And then I got to look at, I mean, to me, that's a good answer. But then we just have to match multiple choice. And I believe C is our foiled out version of that. That okay. We just want to find an easy value of t to solve for and then substitute. All right. 51. What are the rectangular coordinates? That's our normal x, y's. But this is polar. This says we're going to rotate 3/4 pi. We're facing this way. And we're throwing the rock forward a distance of 2. That's where we end up. And we went on a direct line from here to here, but I want to know how I would get there moving like that. I need to know what this value is, what this value is. How big is this angle? 45 degrees, right? Now, normally in a 45, we'd usually call this a length of 1, and this a length of 1, and this a length of root 2. So to get from this distance back to this distance, we divide root 2. So x and y are lengths of 2 on root 2, which is okay, but I'm going to rationalize that one. And I get 2 root 2 over 2. Oh, they're just root 2. So this length is root 2, this length is root 2, but this is to the left. So our ordered pair up here is negative root 2, root 2. Okay. Alrighty. What are the polar equation? What is the polar equation of this? Okay. As an option, desperation, you could graph this, although we ought to know what this thing looks like without going to our calculator. We ought to know it looks like a pretty steep parabola at 0, 0. Then you could set your calculator to polar and graph each of these. And maybe only one of them looks like that in polar. Or maybe 2 do, and at least you got a 50-50 shot. All right. So this is rectangular. I don't want x's and I don't want y's. I want r's and I want thetas. But sine of theta, 2 a.m. wake-up call, is y on r. Therefore, y may be replaced by r times sine of theta. Cosine of theta, 2 a.m. wake-up call, is x on r, so x may be replaced by r cosine of theta. So this equation becomes, in place of y, r sine of theta equals 2 times, in place of x, r cosine of theta squared. And I'd look and see, but I'm a long ways from having that answer in my multiple choices. So this is r sine of theta equals 2r squared of theta cosine squared of theta, and I'm still a long ways off. So algebraically now, what's one thing that really pops out at you when we look at both sides? They both have factors of r, don't they? So I can divide both sides by r, and I get sine of theta equals 2 a single r and a cosine squared of theta. And truthfully, we've been a polar equation for a while. We're just trying to make it look like one of these. And each one of these, r equals, r equals, r equals, r equals. I think I'm going to solve for r. So I would get, and then I look, I know I'm going to divide 2, but if I look at my answers, looks like maybe it'd be a better idea just to multiply by a half. So 1/2 times sine of theta times maybe 1 on cosine squared of theta equals r. And once again, I look at our possible solutions, and yeah, I got a 1/2 sine. This is not right, because there's no way you're going to convince me cosine squared is equal to 1 on cosine squared. So I could eliminate that one. I don't think we're going to get this one, but let's continue on here. I could break this into 1/2 sine of theta, put one of the cosines here. What's the payoff there? Sine on cosine is? Tangent, very good. And I'd be left with another 1 on cosine of theta. What's 1 on cosine? Secant. So this is 1/2 tangent theta, secant theta is r, and I believe that one's on there, d. Here's my suggestion. Both of these two, I suspect, would graph to be opening upward parabolas. These probably wouldn't, so you'd at least be able to eliminate to there. And then if you graph them both at the same time, probably going to choose the steeper one. And that one's actually going to be steeper. But not horrible. Okay. 53, write the polar equations. Well, I don't want thetas, and I don't want r's. Or the polar. I'm sorry. I was getting ahead of myself. This polar equation represents which conic section? Sorry about that. I was thinking about the next problem. Okay, let's go ahead and graph this thing and just take a look, because if it's a parabola, it's going to look like a parabola. If it's a hyperbola, it's going to look like a hyperbola. If it's a circle or ellipse, okay, now I got to decide which it is. But let's go ahead and graph this. You need to go into mode first and make certain that we are in polar. And then when you go into y equals, I'm just going to zoom standard this thing and show you a little bit of it, where the challenge comes. Zoom standard. Okay, is it an ellipse? Is it a circle? We may be able to figure out just based on tick marks. Let's take a look at if the diameter going this way. It appears to be 1, 2, 3, 4, 5, 6 units. Does it appear to be 6 units across? No, from center it's like over 2 and a little bit. It appears to be closer to 5 or a little bit less than 5 even across. But here's a good hint for you. Go back into zoom and go down to square. If you zoom square here, it makes the y-tick values the same. The y-tick values here are the same height as the width of the x-tick marks. And now I'm certain it's an ellipse. Now, if it looks like it's close to a circle, we still have some challenges. But right here, I could just say with all certainty, this thing is an ellipse. Okay, if we're going to do this by hand, I'm going to go ahead and try to convert this to something that I'm more comfortable with. I'm going to try to go to rectangular. I've got r equals 5 on 3 minus 2 times. Let's get rid of sine. Sine I can replace with what? Y on r. I'm going to cross multiply. R times 3 minus 2y on r is 5. I'm not crazy about the r, but I like the y. 3r minus the r's cancel, 2y equals 5. How am I going to get rid of that r? I don't want r, I want x's and y's. What do I know about r? R squared is x squared plus y squared. I think I want to get the r's alone. 3r is 2y plus 5. Add 2y to both sides. And now you could either divide and then square or square now. I think I'm going to square both sides now. 9r squared equals, might as well FOIL this out now, 4y squared plus 20y plus 25. But r squared is x squared plus y squared. 9x squared plus y squared equals 4y squared plus 20y plus 25, or 9x squared plus plus 9y squared equals 4y squared dot dot dot. Subtract 4y squared. 9x squared plus 5y squared equals dot dot dot. Do we know what kind of figure this is? It's an ellipse, isn't it? If this was 9x squared minus 5y squared, it's a hyperbola. If there was only an x squared or only a y squared, it's a parabola. If it was 9x squared plus 9y squared, it's a circle. Right? This thing is an ellipse. But I'll tell you what, I would give my calculator I'd give my calculator a shot at it first. Okay. Okay, which is a way of expressing the polar point 3 pi on 4. So I'm going to graph it. I'm rotating pi on 4 just 45 degrees. I'm throwing a length of 3. I'm reflecting that across theta equals pi on 2. So theta equals pi on 2 rotates around to here. I can throw the rock anywhere I want, but I'm reflecting this across there. So I would end up over here, a length of 3. There's a couple ways I could name this. I could say, let's rotate that angle and throw it forward 3. What would this angle be? Not in degrees. 3/4 pi. 3/4 pi, and throw it 3. Or we could say, let's rotate maybe backwards pi on 4 and throw it over our shoulder, -3. Looks like that's not it. Looks like A. Just A, right? Just A. Okay. So that was the sections we were working on for today.